My name is Theodore Gray. I'm a co-founder of Wolfram Research, maker of Mathematica, which is a technical computing software company. But that's not really relevant here. So quite a few years ago, I started writing books. And one of them is this book, How Things Work, which it's sort of a picture book of many different kinds of technologies and how they work inside. But as a result of this book, I started getting more seriously into product design and questions around manufacturing of these things, both because I was studying it for the book and because I was wanting to do it more myself. So we've set up a little design studio, as it were, along with our photo studios. And we've been using for, 5 or 6 years now, a Eagle laser CO2 laser cutting machine to make acrylic models, much like this one that we've talked about before. So we have a small sort of design studio where we make small numbers of products and we design a lot of things. Having a laser cutter is, I would say, absolutely fundamental to our process because it lets us have a design, make, evaluate, redesign cycle time that's measured in minutes rather than perhaps hours or days or weeks or months for other kinds of ways of going about product design. So this is an example of a product that we designed in a relatively short time. It's a model of an internal combustion engine. There we go. It runs. So this is almost entirely laser cut acrylic using a machine very similar to that one that we have. This is a quite intricate machine. It has multiple gears that work. It has components that fit together, screw together. And designing all of these parts, getting them to work properly, like the valves go up and down the way they should. They don't get stuck. The lifters work. All the gear ratios are right. There's a lot of trial and error involved in that. There's a lot of, many different ways this could be made to work, only one of which is really going to be ideal. And the fact that the parts can all be laser cut means that we could make changes, refine the design very, very quickly, much more quickly than any other way that I know of that you could make these parts. So I was originally in the market for a laser cutter because we were doing a project where we needed to make sort of things that we could photograph which would explain how various different mechanisms worked. Locks and clocks, things like that. How do these things work? And rather than drawing a diagram or picture, we wanted to make physical objects that we could photograph, but that would have the same sort of explanatory power as a diagram. So in other words, transparent models, cutaway models, things like that. And I decided that, well, laser cut acrylic, that's the way to do it. It's transparent. We can make these things. They'll actually work. And so I originally actually thought, I'll just get a little desktop laser cutter. We'll just make one of each, design it, make it, take a picture of it, done. Because the end product is the photograph. The model is irrelevant. But then, I talked to Daniel and he said, well, get one of these. And so we got this, what to us is a much bigger machine. Like I realized this is, I think, in fact, the smallest machine they make, or almost. So this is not by industrial standards a large laser cutter, but for us it was a very big laser cutter. And what we realized was that we could not only make one of these models, we actually have a machine that's powerful enough that we could manufacture these kits and sell them together with the book that the pictures are in. So I was very intimidated when we got our first laser cutter because it's sort of scary. It's a laser, it's the kind of thing that people in movies cut you in half with. But it was I was very pleasantly surprised with how easy it was to get started. One of the most difficult parts of some other forms of automated machining, like CNC machining on a 5-axis mill or something like that, the software is really quite complicated, and designing tool paths, taking into account the dimensions of the tool and how the head has to be able to get in there and what's going to bump into what, and it's quite an elaborate process. You need a significant period of training to learn how to use the CAD/CAM software to operate those things. Because laser cutters of this type are fundamentally two-dimensional. Of course, that limits what you can do with them, but it also means that the only thing you need to drive them is a two-dimensional vector file, something you could, draw in almost any, Adobe Illustrator or whatever your favorite vector program is. You don't even really necessarily need a CAD program. I tend to use a CAD program just because it's more convenient for making dimensionally accurate things, and it has features that are, that are good. But you're not, you can learn in a few hours all the commands you need in a simple CAD program to make these simple, flat, two-dimensional shapes. And then you just, you need to say, well, how much power and how fast is the head moving, which is determined by, are you cutting 1/8 inch acrylic? Are you cutting, 3/8 inch steel? So we now have a whole line of acrylic mechanical models. We have about 25 different kits you can get. There's steam engines, there's lock mechanisms, combination locks and key locks and things. And they're all clear acrylic, all laser cut using our one laser cutter. And so the reason that we have those kits for sale is because we got a laser cutter that was much bigger than I'd originally intended. And that opened up the possibility of actually manufacturing rather than just designing. And, it's just beautiful. For example, it's much more attractive than mechanically cut acrylic, because if you saw cut acrylic, the edge is then rough and sort of a diffuse, milky sort of surface. If you want to have a glass surface, you have to polish it, which you either flame polish it or you have to sand it with progressive grits and then flame polish it. It's a big operation to get a glass, transparent sort of glass smooth edge. With a laser cutter, that's just what you get. You get flame polished edges automatically. So the acrylic pieces are as attractive as anything you can make out of acrylic right out of the box. I've had an Eagle Laser CO2 laser cutter for 5 or 6 years now, and I found it to be tremendously useful, interesting, inspirational machine. It's sort of frustrating to me when I see almost anybody who makes anything, woodworkers, artists, fabric designers, who don't have a laser cutter, because it's just so clear how much more efficiently they could do certain things with a laser cutter. It's a surprisingly flexible, versatile machine. So I think laser cutters and laser welders have a tremendous potential for growth in use around in many different applications. There are quite a few people that have small desktop laser cutters these days. They're popular in sort of maker spaces and hobbyists and things like that. These are very small desktop machines. There's a smaller number of larger machines like this, but they're really not very widely used in industry or in design firms. There are some people that have them, but I think there's a lot of other people who don't have them, but who probably should. And the only reason they don't is because, I think they have a reputation of being extremely expensive, which is changing rapidly. Eagle Laser is introducing these machines that are significantly cheaper than what some of the older machines are. So, if you think it's too expensive, probably not. They've gotten a lot more reasonable. And people are also just sort of, scared of new things, unfamiliar things. And lasers are, look at this thing. This belongs in a Star Wars movie. It's literally a ray gun. You could imagine people being a bit nervous about pointing a ray gun at something. But, when you see it and you actually use it, it's surprisingly, well-controlled, understandable technology that compared to, for example, arc welding. Here we're talking about laser welding compared to arc welding. Well, arc welding is not exactly the safest thing either. You have to have all kinds of protection around it. It's no different with the laser. And the laser is in some ways, gentler and more controlled than many other, the other standard welding processes. So I think there's a great potential as people realize that the machines are not actually that expensive, and they're surprisingly easy to learn how to use, and surprisingly, easy to fit into an existing manufacturing setup. You're sort of replacing one form of welding with another. And in those situations where laser welding has particular advantages, it can be a tremendous improvement in efficiency and speed. As I've said, I've several times been interviewed and asked for like a list of my 4 favorite tools. There's a book that's somebody went around and asked many different people, what are your 4 favorite tools? And my Eagle laser cutter is always on that list because that, along with a handheld bandsaw, they're just beautiful machines, and they enable so much, in terms of both design possibilities and actually making useful things.